Welcome back, guys. This is CIT 225 Network Security and Penetration Testing, and we are covering a book called Guide to Computer Forensics and Investigation, 6th edition. Um, we are starting another chapter today called Current Digital Forensics Tools. So, we'll be looking at different forensic tools and how they are used in the organizations and in the industry when we are conducting any forensics analysis. So objective of this chapter is explain how to evaluate needs for digital forensics tools. Then we'll describe the available digital forensic softwares which are out there in the market. Then we'll list some considerations for digital forensics hardware tools because we usually recover the data using the hardware forensics tools and sometimes the software forensics tools. Then we'll describe the method for validating and testing the forensic tools. So first of all, we evaluate the digital forensics tools that we are using on our daily basis for investigations. We'll have to consider open source tools and the best value for as many features which are available. It's not mandatory that if you are using a paid tool, all the features will be available out there. There are lots of tools available on open source or open source websites where you can download the tools and they work equally good as the paid versions. The only difference is that if you are using a paid software, you'll get some support from the vendor, whereas for these open source softwares, there are forums, but there is no direct help available for that. On the other hand, the open source softwares, they have frequent updates and they keep on updating the features and different functionalities inside the softwares. Now, the questions that you may ask yourself before choosing a tool is that on which operating system this forensic tool would run. If you are conducting analysis on Windows-based operating systems, you'll have to choose if it's working with cross-platform. Yeah, means that Windows XP all the way to Windows 10, or if it's meant for Linux or Mac operating systems. The choice is yours because you are the best judge to know that which operating system is being deployed in your organization for the server infrastructure as well as for the client computers. Is the tool versatile? Like, is it able to conduct the analysis on only one operating system or it works on different operating systems? Can that tool analyze more than one file system? We covered file systems in our previous chapter where we were talking about NTFS and FAT32, EXFAT, etc. Can a scripting language be used with the tool to automate the repetitive functions and tasks? It means that sometimes we run some scripts in order to automate the process if we want to conduct analysis on a specific kind of Word documents or PDF documents or Excel sheets. Or does it have automated features where it can automate the process itself? And usually these kind of features are available in a graphical user interface. And what's the vendor's reputation providing product support? That's what I was talking about when you are getting the paid softwares from the market, that how good is the vendor in providing you support for those kind of softwares. Now here in this slide, we are covering type of digital forensics tools which are there. Some are software forensic tools, some are hardware forensic tools. Now the difference between these is there are hardware devices with the help of which we can create a complete replica or a bitstream copy kind of a thing between two hard drives. We purchased a hardware device long time ago for investigations where if you are connecting one hard drive to a computer and if you are one hard drive to the device and you are connecting four different hard drives with the same model and everything, it would create 100% replica of the primary hard drive, or you can say a suspected hard drive with the other hard drives in one click. So it was a hardware device, there was no computer connected to it. All you need to do is just toss in the hard drive, the primary one, and it would create a replica on three different hard drives. Now that helps in investigation because it's creating 100% copy of the primary hard drive, so that you can use those hard drives connected to the forensics machines and conduct the analysis. So if you have three different machines on which you are running different softwares, there are high chances that you'll be able to recover or you'll be able to find what you are looking for in a very professional and faster manner as compared to conducting analysis on a single hard drive. It comes in with different SATA ID and eSATA bridges. That is a single purpose component that makes it possible to access the a SATA or an ID drive with one device only. Now there are some software forensic tools as well. Now software forensic tools are grouped into command line applications or GUI applications. Some tools are specialized to perform one task, for example SafeBack and other applications which are available out there. Commonly used to copy the data from the suspect hard drive to an image file. And as we have checked the Passmark software and other software which comes with graphical user interface, you can select different options. It has a hex editor, it has a hex viewer, and recovery tools. It comes in bundled with lots of tools which you would require when you are conducting an analysis. Now we'll try to understand what are the tasks performed under digital forensic tools, and there we'll have to follow certain guidelines which are set up by NIST, and it's called the Computer Forensics Tool Testing Program. It's backed by an ISO standard 27037, which is a digital evidence first responders should use to validate the tools. They fall into 5 major categories called acquisition, validation and verification, extraction, reconstruction, and reporting. Now, in order to explain acquisition, making a copy of the original hard drive, now acquisitions of functions are physical data copy, logical data copy, and data acquisition formats and different guidelines, command line acquisition tools that we use in a graphical user interface acquisitions, or if we'll see for the remote or live memory acquisition. Now here the thing which is very important is whether you must be conducting an analysis based on the physical data copy or the logical data copy. The only difference between a physical and a logical is that if we are conducting the analysis on a hard drive, we'll have to make sure that the data is 100% intact, and you don't know if the hard drive was actually encrypted. So in order to avoid those kind of things, we always go for a logical data copy. It means that it would be a live acquisition of the data when the remote machine is powered on and it's working. If you'll create a physical data copy and later if you'll find out that the hard drive is encrypted, there is nothing much you can do. Whereas on the live data acquisition, you have the chances to recover the data since the machine is powered on and its encryption is not active, and you can directly copy the data from the machine. Now on next slide, they are talking about 2 types of the data copying methods for acquisition. As the physical copying, as I told you, the entire hard drive would be copied, but if it's encrypted, it would be a very difficult task. Logical copying of the hard disk works for live acquisition, but for that you need to have certain softwares installed on the remote machine so that from the remote server you can access the data of the remote computer without notifying the suspect that an analysis or an investigation is being conducted on his or her machine. The format of the disk acquisition varies from raw data to vendor specific proprietary data, or what you are actually trying to conduct the analysis. And of course at the end, the image file which is created, it could be read by any hexadecimal editor. As you can see over here, there are lots of different tools available out there for data analysis, and WinHex is a fairly good one. And as you can see that they are trying to investigate a JPEG image, and that's the data that you can see in that one. It would even show you the path of it, the file size, and then it's coming to its different level of the data creation date and last time when it was written, plus its attributes that we covered in our previous chapter. And then even the character set is appearing over here, whether it's ANSI or ASCII character and bytes per page, etc. So those are the details that you can find in a typical WinHex editor. Now, creating a smaller segment files is a typical feature of a vendor acquisition tool. Remote acquisition of the files commonly large organization. Most of the tools which are used on the huge companies that they want to conduct huge analysis are access data and NKS and remote acquisition for the forensics drive image over the network. Now we'll see the validation and verification, which is very important when we are conducting an analysis, because we'll have to validate the data and then we'll have to verify it. A validation is a way to confirm that the tool is functioning as it's intended to perform. Verification is once you'll get the data, proves that the two sets of the data which is identical of calculating the hash code using the other similar method, or related processes filter in which it involves the sorting and searching through the investigation and findings to separate good data and a suspicious data. Now we'll have to understand what is a good data and what is a suspicious data. Good data is the data or the files which came in as when the Windows was installed. Like they'll have certain hash code with it, which remains the same, and if there is a difference in the original hash code of the files, like the operating system files or the Word documents or Excel sheets, we can compare it with the initial hash code that we have collected once the Windows was installed. It could be CRC32, MD5, SHA. It could so once we collect that, we can conduct a filtering based on the hash value sets. Now, how to do it? As soon as we'll install an operating system which is a fresh with where we are 100% sure that the data or the files has not been altered, we'll conduct the initial analysis and we'll take the SHA or MD5 codes of all the files which comes in pre-installed, especially the operating system files. Later, once we are conducting an analysis and we'll get the files from the suspected hard drive, we'll simply compare it with the code that we had initially. So all the files of the operating system which are with the same code as we conducted a snapshot earlier, we'll ignore all those files. So we'll be working on the files which are a bit suspicious, which we call a bad data, and then we'll be conducting analysis on that. So based on the value sets and discrimination and the files based on that, and then we have this National Software Reference Library where we have all the basic information about the hash codes and even the software which we can use in a specific kind of analysis. Not every time you'll have to conduct analysis on a PC or a server. It could be a tablet, it could be a mobile phone, it could be any different kind of storage medium. So here you can find lots of information about the device and what kind of analysis you'll be conducting on it. Many computer forensics programs include a list of common header values which are the same for them. With this information, you can see whether the file extension is correct or something is happening with that. Most of the forensic tools can identify header values, and then from there it would be comparing it, and here again with the hex editor they are showing it. Now that's the file where we are conducting the analysis on it. The file filter document cannot be opened because there is a problem with the content, and it would show you an error message because you are trying to open a document with the name of dog, though it's a JPEG image. And if we'll change the extension of it, we'll be able to see a picture. Now that's very important because by default Windows 10 is not showing you extensions of the files which are installed on your computer, or the documents or text file or anything. So it's a good way to inform your guys or the employees in the organization to uncheck that option to show the known extensions, and they must be aware of the extensions they are opening. For example, text documents, Word documents, Excel sheets, and PDF documents. Now since this extension is hidden and you don't know if it's an executable file having a logo of a Word document or an image, or it's actually an image or a Word document. Now all these hackers who are sending different kind of files to your computers, they'll try to hide their identity by sending the files to your computer which would look like a Word document or an Excel sheet or a PDF document, But as soon as you'll double click on it, it would be an executable file which will be executed, and then it would start spreading either inside the computer or over to the network. Now, so for the extraction, for example, the data viewer or the keyword searching, or we'll decompress and compress the file, or carving or decrypting the files, bookmarking, and we'll be conducting different kind of search analysis on that. As you can see in our OS forensics, we have search index through which we can search for a specific term, and it would give us an index file of all the documents and the files which are located in that directory. Now, if you want to conduct these kind of analysis on a file specific search, everything from WIT tools is a very good tool which goes very deep in the operating system, and its searching facility is very advanced. Of course, it won't give you the details about the SHA code or the MD5 code, but if you're searching specific files, even the operating system files, you can use the tool to conduct those kind of analysis. Now here they are also trying to search it with a specific criteria like case sensitive, match the whole word or multiple words. If you found a file which is a little bit suspicious, having a certain kind of extension or the file size, you can do data carving by giving the options over here, and it would be searching and showing you the results as per your requirements. From an investigation perspective, encrypted files and systems are a big problem because it takes a lot of time to decrypt it, and many password recovery tools have the feature to generate potential password lists, for example, password dictionary attacks and other things, or brute force. But in that kind of a situation, you might require a very powerful GPU as well in order to save your time to conduct these analysis. If a password dictionary attack fails, you can run a brute force, and for that you'll need a huge computational power. Now in Reconstruction, we try to recreate a suspect drive to show what happened during the crime scene or an incident. Methods of reconstruction is disk to disk copy, or partition to partition copy, or image to disk copy, or image to partition copy, or disk to image. These are the different kind of images or copies that we create. Of course, these options will be appearing in the software that you are using, but you'll have to choose that which feature would you like to use and which is best likely to give you the best results possible. It would rebuild the files and the data by the data carving to recreate the image of a suspect hard drive, copy an image to another location such as partition or hard drive, either on the same computer or somewhere else on the main machine. Now, I don't agree with that to create an image on a separate partition on the same computer, because we want to preserve the original copy of the evidence. The simplest method is to use a tool that makes a direct disk to disk image. Lots of good imaging softwares are there which even verifies the data, and it locks so that nothing is changed on the source hard drive. Examples of multiple disk to disk tools are Linux DD. It has some disadvantage for Linux DD command because it creates a flat structure of it where you cannot see the files which ever existed on them. But if we are using ProDiscover or any other software like that, it takes a time, but it would even try to find the files which were deleted but are still existing somewhere on the hard drive, so that you'll get a good healthy state of the files which were deleted as well, and then you can conduct your analysis on them. Now next we have reporting. In order to perform the forensic analysis and examination, you need to create a report with sub-function reporting, bookmarks, and tagging and log report. That's all about the reports that we generate usually. And then we have different considerations for flexibility, reliability, and future expandability. If we can expand in that direction, create a software library containing older versions of forensics utilities and tools and other stuff. Now, one thing which comes to my mind over here is, instead of building a huge library for forensics and analysis and all those tools, if we are taking help from the forensics analysis labs, which have the latest and sophisticated equipment as well as the physical forensics analysis are concerned or logical analysis are concerned, they have much better tools available in their libraries than what you can acquire in your organization. Of course, you won't be conducting analysis on daily basis. An incident takes place after a couple of months or 3 or 4 times in a year, so you won't be spending a lot of money in creating a huge library and computers which are equipped with lots of tools and all those things. Yeah, basic kind of setup is required for basic analysis, but if you want some professional analysis, I think it's a better way to approach the forensic labs, which are very well equipped. And since they that's their business, that's what they do, so they are spending a lot of money and in maintaining and finding the best tools available out there, whether they are hardware based or software based, in order to get the excellent results and reports. Now, the following section explores some options for command line and graphical user interface tools in both Windows and Linux. Now, command line forensic tools are those which are used to analyze or extract the data from the floppy disk or hard drives where MS-DOS tools or IBM PC files or systems are there. Quite obsolete these days because most of the recent even desktop computers are not equipped with a floppy disk drive. And you can even use Norton Disk Edit to find the MS-DOS tools in the computer for investigations. I'm not denying the fact that command line is the fastest way in order to investigate anything. You need very few commands in order to acquire the data, which you cannot see in most of the cases on the graphical user interface. But then it has its own disadvantages where you cannot see things in bulk and with details as you see with the graphical user interface. Command line tools require fewer system resources, so you can even use very light computers in order to conduct the analysis where the computational power is not an issue. Unix has been the mostly replaced by Linux, so you might still encounter systems running Unix systems, and Linux platforms have become more popular with home and business end users, and they have a smart thing which is designed to be installed on numerous Linux versions, can analyze variety of systems and then plugins and other options which are there for Hex Viewer. Now keep in mind that this smart is different than the smart which comes in Windows based systems on BIOS level. The smart in Windows is the tool or the utility which gives you the overall performance, and it's an early warning utility which is installed on the computers to let you know if your hard disk is going to fail. So it would keep on checking it once you restart the computer. But Linux it is for the investigation and other kind of purposes. Now you can use different tools for that. For example, Helix is there, or Kali Linux, which used to be Backtrack. And now Kali Linux is bundled with lots of tools which are pre-installed, and you can add certain libraries to it as well if some things are missing, which helps you in the investigation part. And if we are installing it on Windows machines, we have Autopsy and we have the Sleuth Kit, and the it's a Linux-based forensics tools. And we tested Autopsy in our first lab exercise, and face point threat protection, formerly known as the second look, was another one, a Linux memory analysis tool, because some of these kind of viruses and worms, they are sitting on the memory, and they are trying to launch attacks from there. That's it for today. We'll be covering this material in our next lecture. Thank you very much.